Hello, good afternoon, everyone. We're about to start the next session, the first session in the afternoon, and I have one information to give you. In case you haven't realized, we are more or less at the equator of the General Assembly. So if you haven't started to do your networking or your discussions with all the people that you wanted to discuss, it's the time to do it because we have stopped thinking about its starting and we are changing focus to its finishing. And this mix of time scales and this interface between the future and the past, it's also a nice way to introduce us to the next session this afternoon. So far, yesterday and this morning, we have been talking about observations, monitoring, attribution, words like reanalysis, ECVs. I know the linguist in you is telling you that ECVs is an initials, is not the word, but you guys, you know what I'm talking about. And now we're about to change the focus. We will start to talk a bit more frequently about models. We will talk about predictions, about projections, about initial conditions. Again, that's two words, not one. But that's what we're talking about. And these are the parts of the components of the service that will help us, that helps us to try to prepare to adapt to what's coming next. And with this next, we can be thinking about the coming months, the coming 5 years or so, or the time when the kids that were born in the 2020s, they will be taking the lead in organizing gatherings like this one. And this is the kind of components of the service we will be talking about this afternoon. We will start from the user's perspective, and from the climate predictions realm, and then we will move to the vision of C3S about the climate predictions, and then about the climate projections, to move forward finally about the climate projections on what we can expect next, in the sense of what are the challenges, what are the plans, and what are the challenges that we will be facing. And without further ado, I want to introduce our first speaker. He's Esteban Rodríguez Guisado. He comes from IMET, the Spanish Met Service, where he leads. He's the head of let me read it, of the climate evaluation and modeling area in the Spanish Met Service. And he will be talking about, also in his role as a MEDCOF coordinator, he will tell us what is MEDCOF, and yes, in a minute. And yeah, well, I'll leave you the floor.
Well, hello, everybody. Good afternoon, and thanks, Edu, for the introduction, and thanks for the invitation to opening what I think will be a very interesting session. So, climate prediction. We have been talking about changing climate, extremes, how we characterize the climate, but what can we say about what is expecting us, in which part of the distribution of possible climates are we for the next, in the short term, for the next season, or for the next several years. So what we do is just run our climate models, initializing for the whole set of components of the climate system to try to see how our possible climate distribution for the coming season is behaving against a reference climate. But what happens is, when doing this, is that we do have a signal-to-noise ratio is relatively low, particularly mid-latitudes, and so is a skill. So what happens is, when running different models, many times signal tend to differ. So the recommendation is to integrate different sources of information and to build a multi-model. The other problem we usually face is that, as complex as they are, models present some bias. So we need to build, as Anga was pointing out this morning, a set of forecasts that provides a reference climate and allow us to compute some skill scores. But this is really a huge computational effort. So in the risk of having divergent information and to produce different forecasts analyzing the same set of information by different experts, WMO sets a structure of different layers to try to set a standard, as standardized as possible procedure when producing an operational seasonal forecast. So the first step, the first layer are the global producing centers. If we do need to build a multimodal ensemble, we need to set up a series of requirements for the different models and predictions to fulfill, so they are compatible enough that allow us to build a multimodal ensemble. We then have a layer of regional climate centers that provide a layer of analysis, diagnostic products on those elements of the climate relevance for predictability for each one of these regions. And then comes the regional climate outlook forums, to which I belong. I'm currently MEDCOF coordinator, the Climate Outlook Forum for the Mediterranean, where we bring together experts from NMHSs for the region, for the regional climate centers. We're trying to put on the table all the knowledge, all the expertise that we have to analyze the situation together, to share all the tools. We do have activity and capacity building and training, with the idea on one hand to provide harmonized products, harmonized climate predictions for a wider area, and on the other to bridge the gap between research, between operational centers and the users. So many of our activities actually do, I don't want to say overlap, but can be done together or with the support of C3S. Here is just a slide on the current procedure, courtesy of Meteo France, in which we start from oceanic analysis, then analyze the ocean forecast, how that is affecting, and are the teleconnections through the atmosphere active. All of it into a process of discussions to produce this kind of maps. We produce them twice a year. As I said, Copernicus service and the multimodal system provides us basic information to make our analysis, provide relevant information for discussion, and being user-driven, the Copernicus team has always been available for discussing with us, for supporting the activity and taking into account the demands that we may have. This is just a snapshot of the graphical products web. In what the plant allows you to see, we have available spatial maps. We have for 3 and 1 monthly aggregated surface variables and some impressor levels, and constantly new products that are considered relevant for the analysis of the climate situation and for the climate forecast are incorporated, as like these ones on the sea ice extension, or these plume diagrams with the relevant, over-relevant areas of the ocean. But in this procedure, as you may have noticed, is completely subjective, and this has several drawbacks. It's not easily traceable, it's not suitable for objective verification, and we just provide the maps. We do not provide gridded data. So we are not completely solving the problem that may be producing different forecasts analyzing the same information. WMO is aware of that and endorses a transition in the scope of the regional climate outlook forums to try to set up a different way of follow their operations, and produce a guide with recommendations and principles to try to produce or to substitute this subjective analysis procedure for an objective one, in which we introduce our expert knowledge in an automatic selection procedures, incorporating information of the relevant knowledge on predictability, observational information, selecting the information, calibrating with a flux from the general or the synoptic scale to the regional and local scale. So we are changing the emphasis of the expert knowledge in discussing about the more likely anomaly pattern in the circulation, trying to apply it in the way of in how we select the information and how we combine it to produce gridded forecasts that allow for objective verification and to coupled on-scale applications. Actually, there are some interesting works by several groups pointing out some potential on improving the skill of a forecast, blending with observational information with empirical forecast. So one of the first points is a discussion that is actually taking place with gathering the different relevant actors, C3S team among them, on, okay, there seems to be some potential, but one thing is having that, and the other one is to implement that in a manageable operational framework. So we need to argue about how do we introduce or generate the operational data flux to be able to maintain such a system. But I would like to mention another couple of points that as a user of the system would be interesting for us to have a discussion about. One is the inclusion of extremes and daily information. So the point of climate prediction is to try to provide some information, as I said, on how, in which part of the climate distribution are we going to be in the next season, or if it's more likely to have extremes in one particular side of it. And we know actually that this, in a world of a changing climate, this is particularly relevant as the number of extremes is rapidly increasing, or climate is producing more extremes. And because of this low signal-to-noise ratio and the lack of skill and the bias, traditionally most of the seasonal forecast products has been produced as averages for the whole season. But I think that really we should discuss the possibility of, as it is done, for example, in the scale of scenarios, and it is done in the interactive climate atlas, to build some indices with daily information with likelihood of surpassing thresholds or to reaching certain extremes. So it is something, of course, the approach should be slightly different. We have challenges there, but I think that trying to explore what has already been done in other scales could be incorporated to seasonal. And if I were to write a letter to Santa with, okay, what would be ideal? We were talking yesterday about reaching the society, about communication and the importance of visualization of products. And I think an important effort has been done for the Interactive Climate Atlas. Important efforts have been done for the climate reports. But I think that something like that, we could try to explore the possibility of doing something like that for the climate predictions. So having dynamic maps instead of static ones, and being able to extract grid point-wise information from it, as it is done, for example, for subseasonal, would be interesting. So ideally, we would be able of providing an idea of how the forecast is evolving against its own climatology, as it is shown here in gray. This is done for some interesting, for wide averaged areas or for variability patterns at ECMWF seasonal forecast web, showing the information of the forecast with some information on the skill, on the scores, on how is the performance of the model for this particular grid point. Ideally, we should be able of spotting here information for different models to see the consistency, and for different lead times, particularly for some seasons such as winter. All the lead 2, lead 3 runs show significant skill. Even including some graphics as these ones that are already plot for zonal, for a stratospheric zonal averaged wind, would be interesting in the sense of having an ability of watch just in one side how the whole ensemble is evolving and behaving against climatology for that particular grid point. So just to conclude, C3S multi-system has become essential in many users' operation. I've been talking about Metcov, but for national Met services really provides a step forward in the sense that we have homogeneous gridded data with longer hindcast that allow us to generate different products downstream. But we feel that the demand for climate predictions is growing, and that improvement on the visualization of products will help to attract some users, even when having some challenges, to attract them and to start discussing specific products that may suit their needs. And I think that we may need to have the discussion of if it is possible to include some information on daily based products and the probability of surpassing certain thresholds. But I hope it's a discussion that we will have in the next few years. So thank you very much for your attention, and I'll be happy to take any question now or later or whenever you want.
Thanks, Esteban. I think we have time for a quick question if it's about a clarification. Yes, please, Harry. Yeah.
Hello. You showed in your diagram how you process the data with the final step of downscaling. The Copernicus Climate Service provides the forecast at the resolution of 1 degree, and you probably know that users are obsessed with high resolution. Do you think it makes sense to go beyond this 1 degree resolution and provide high resolution?
I think
in terms of scientific and skill quality.
At least in our case, one part of the uncertainty or let's say the error comes for the resolution. Even given that our model really mimics the anomaly pattern that is going to happen in the circulation, the resolution from models prevents them to accurately reproduce, for example, precipitation maxima. So at least in our case, at the national level at Spain, certain techniques of downscaling can provide additional skill. The thing is, as it was pointed out this morning, a balance between having more accurate information or products and have an amount of information that is manageable. If you have a 300 members ensemble of a 1 kilometer resolution, something that's very difficult to manage by the users. I think that going to higher resolution may help, but I think that is something that can be done more by the end user or national Met services, and that we may have more room calibrating at the same resolution we have and exploring other ways of generating better visualizations or incorporating additional products, more than doing the same we are doing at a higher resolution. But that's my opinion.
Thank you very much. Thanks, Esteban. That was a very nice talk. Thank you very much. And now we will be moving to the next talk. And I want to introduce you Anka Brookshire. She's the leader of the Weather and Climate Products team at ECMWF. And she has been leading the climate predictions and projections activities at the C3S since the service inception. She will now move to the perspective, from the perspective of the users to the perspective of the service, and talking about what of the next upcoming upgrades and changes and what we can expect next. I'm going to move the plant.
Thank you very much for staying to listen to this presentation. I hope that I have few things to say compared to the last few years. I turn up pretty much as an assembly and go to the same point. Okay, so I will try to keep the interest of people who've never heard me talk about this before by going very quickly through the summary of what we do. but won't dwell on it as much as I might have in the past. So we are basing the seasonal forecast service, component of the service, around the same concept that Esteban very nicely introduced, the WMO has promoted, that of the multi-system. We currently have 8 components, which is coming quite close to the full number of GPCs from WMO. All of these are GPCs. Soon we will be adding another, so by the time of the next General Assembly, I should be able to show you this picture complete. This is the Australian Bureau of Meteorology's outputs. They in kind will contribute to the C3S multi-system. We create data products, and here maybe I should add that whilst we do parallel what WMO is doing, we have a much longer list of variables, much higher temporal frequency data, which would allow people downstream of the service to create all sorts of added value products based on weather kind of information and on daily, sub-daily data, as long as they can persuade themselves their skill. This is one of the things that Esteban didn't tell you, but we've been working with them for a couple of years in trying to develop applications and tools and setups in which they can extract this information and process it every time they have a Medcov session or every time there is in a region any kind of need for this, using our data, but not doing it generically for C3S as a service. We do have graphical products here. Not much has changed from the last time we met. What has changed is a bit more in a way of workflows being published. We are trying now to put all the code that we use to create our static maps as Jupyter notebooks, so you could be able to get that data. Now, in addition to that, we are trying to publish the data that is in those plots as ready for download. You would have heard me say this before, but this time we plan to do it. So, but more urgently than that, more promptly than that, sorry I put this at the very bottom, I didn't want to damage the big picture, nice picture. I've written what's coming soon. So there will be updates to the forecast systems for 4 of the components in the next year or less. So you have to be prepared if you use this data to update your setups, your production flows. There'll be the systems from Canada, Italy, Germany, and France. We will be, and you've heard me say this every time, we will be publishing data on soil moisture. You can laugh if you want, but I hope that before the end of summer, you will be seeing data on soil moisture, and that will be a taster for the new way we will be encoding the seasonal forecast data, that is to say in group 2. So I hope you enjoy it. We also work on sea ice concentration indices. You might have remembered that last year we mentioned that we are starting a new set of products. What I want to do here is just to give you, using this example, a taster for how we do generate products. So here, as I said, we have been producing the maps. You might have seen them last year. Chris Goddard very kindly put things together for us at the time. I think he had a poster on this. Regardless, we have been publishing these since July 2023. We have maps in which you show all ensemble members with the model climatology, the forecast statistics, if you will, as well as the observations. That allows you, just like in the climograms that Esteban showed us, allows you to see the full model output as an ensemble. It allows you to see the biases and allows you to interpret the forecast in a particular way. This is a very special domain, though. When you look at it, you'll realize that if you are thinking about the total extent, which is only one small part of the problem. The geographic pattern of anomalies in ice cover do matter a lot. However, people are still monitoring sea ice extent. So with that in mind, bearing in mind that the basin is finite, so you can't get biases in the way of too much ice beyond a certain point because you run out of domain. So what we want to do with this new index, which people are asking for, is to follow existing monitoring products. There are such products from NASA's National Snow and Ice Data Center, as well as from C3S, as you would have heard yesterday. We currently haven't done any evaluation, but we draw on results published in literature at the beginning. Then we will need to put verification in place because this is something that doesn't behave in the same nice way as, say, temperature at seasonal timescales. But also we think it's important to convey the complexities and to include them and expose them wherever they have an important message to pass. You'd think it's quite straightforward. We are just going to look at the anomalies, and just like the Niño plumes, we are going to put some lines, and then we'll put the observations through. That may end up being what we do. But also we have to remember that sea ice cover has a particular seasonal cycle. And here it's a bit like the meteogram or the climagram we saw before. In orange, it's the models, the statistic of the model climatology. In pink is the, and in gray are the elements of the current forecast. This is just one forecast. I forgot to mention, you're not going to be seeing it here. It's May 2023 initial conditions covering 6 months into the future. And the observations is in a solid black. So I think this is the example on which you'll see more clearly the differences. So in yellow is the model climatology. In dashed black line is the observed climatology. So that's the bias of the model, if you will. Pink is the mean of the forecast, the median of the forecast, and black is the observation. So in this case, if you knew how to read the forecast correctly, which is to look at the offset from the model's climatology to the forecast statistic, you would see there's about this much at the minimum of the ice, and it's roughly the same as the difference between the observation and the observed climatology. We can talk about it more next. But look at this, how much this kind of presentation tells you. It tells you the models have significant biases, which may or may not be reducible. In this particular case, in the case of this model, it also tells you that this model doesn't stand a chance. It has a sea ice mask that is so coarse that the domain is probably constrained to be something else. So if you just saw the differences between these lines in a set of indices, you may not know what to do with it. You may not know that this is what's underneath the bonnet. When you do put the thing together, this is what it comes up as. So have a look. Some models went for a higher than usual maximum. Some models went for a much lower than usual maximum. Again, the dashed line is the observation. This is what happened in 2023. The minimum is in September, as you might be familiar with. Some models achieved or predicted the minimum to happen earlier, or the minimum anomaly to happen earlier, and all sorts of stories. If you throw all these lines on the same graph, you would be none the wiser. You would see just a big splodge of gray and have no idea. So we're still working on trying to extract this information in a most useful way, and we're working with people from the Regional Climate Center representatives to be able to put something useful. Very quickly, workflows and examples, data tutorials, workflows to detail what we do in the products, and analysis to answer user questions. We are preparing as Jupyter notebooks in anticipation of the new toolbox of the Climate Data Store. In particular, we had a request from Australia to show forecasts for TMIN and TMAX. We judged that putting those routinely for global maps in a public domain is probably too much, but we are preparing a Jupyter notebooks for the Australians to extract the information. Now I want to go beyond 1 year, beyond 6 months, beyond seasonal, and smoothly move to predictions on longer timescales. 1 year or more than 1 year predictions ahead. Well, ECMWF has been doing this for a large number of years, certainly since the dawn of SEAS 5, where we have every 3 months, we do have a forecast for 13 months into the future. We only published NINIO 3.4 from this, but the data is available not to everybody openly, but it might be soon. And here you can see the example of the last 6 such forecasts. In red is the forecast, in blue is the observations. And as you can see, the observations all end in last month, in May 2020, or in April 2024. And you see how well the forecast picked up the signal. So this has been there and is publicly visible all this time. This is the skill. So you can see that this is a metric of skill. Let's not worry too much about what it means, because on the same plot you can see the skill of the forecast and the skill of persistence. Imagine that your next best thing, what would you do? Would you think if you didn't have the forecast? Well, you probably think it's going to continue this month as it was last month. This is the persistence forecast, and the skill of that dies after, in this particular metric, the numbers to the top of the larger numbers are better. So the persistence drops immediately, whereas the forecast continues for longer. It seems to be bound by the spring predictability barrier in year 2, but let's not dwell on that too much. More and more people are asking about global average temperature. what's it been like, not least in the last 12 months, what is going to be like in the next 12 months? And I know many people in this room have asked that question. So once that was asked once too many, Edu put together this particular piece of work, and I have a couple of messages to take home from here. So for those who can't see the labels, there are two blues. One refers to the reforecasts from May and the other from November. I didn't say that, well, I did say that it's 4 times a year. Here he picked just 2 times a year forecast, and in blue is the reforecast part, and in red is the real-time forecast part. So firstly, I was impressed, and in black is the ERA 5 value for the same index. I was impressed at how well the forecast followed the observations. If you look at the details, you will see some things, some misses. It's a small ensemble. It's only 15 ensemble members. But I think, by and large, it's not bad. It's all initialized a month before the beginning of the 13-month period, which is why these are not, I said something wrong, a month before the 12-month period. These are not annual, these are not calendar years. These are the month 1 to month 13 of the forecast range. So there will be June to the following May, or December to the following November. And you may or may not want to dwell on the latest forecasts. I will come back to it if you want to know more. Now, how confident are we that these things are ready for operations? What exactly can we produce more than just ENSO and possibly global average temperature forecast? Well, there are research projects that have been set up. It's not the first, it won't be the last, I suspect, to answer some of these questions. In particular, this is the project that started last year called Aspect. You will see posters about it, which try to take the angle of climate adaptation and think about the type of decisions users make and how the modeling framework and the prediction framework in operations fits the needs of users. There's a number of selected objectives. You'll see these on a poster upstairs. I won't dwell on these. I will only say, because I really feel the need to acknowledge the efforts of people in this room, you will find things here that several of you have done in the past. This is maybe a new approach, looking at merging timescales without any prejudices, a priori prejudices, but in principle is not very different. What I like to hear and to see here in particular is the idea that the project from the beginning would be looking at possibility of scaling up these things. It's one thing to talk to users and to understand what they need, but is it for something grand as large scale as the service to then deploy that routinely? If it's not, it's just for a tiny user who could very easily have the technology to do it themselves. What I would like to see, though, because I don't see it explicitly on a poster, it's a very simple and superficial poster, but I understand that this is in play, is thinking about how you do evaluation, evaluate the relevant, user-relevant variables, and evaluate it in ways that match the decision. Looking at correlations over 5-year means, over a 6-year period, has value, but not to has merit, but it's not, and helps you compare models. But I'm not sure that that is necessarily going to give you the answer about how useful a certain thing will be to certain users. Lastly, here's an example. Again, I was telling you that CIS5 has already been doing this every 4 months, producing, I did say every 3 earlier, 4 times a year. It produces forecasts that are 13 months long. CIS6, which is due to come into operations next year, will be enhancing that and then some. So every month we will be running forecasts to 13 months. Every 6 months we will be running forecasts to 24 months. And in addition to what's done currently for seasonal, every month we will be adding an initialization day halfway through the months. The ensemble sizes will grow, and there will be a supplementary set of reforecasts going back to 1961 to be able to better assess predictability on the 24 months timescales. This is aligned with the protocol in the Aspect project, the experimental protocol, and it's quite well aligned with the plans that the Decadal Climate Prediction project, part of CIMIP, is putting in place for the 7th round of modeling the comparison projects. One more thing I'm going to say without showing a slide. I think some people are wondering what implications this will have for the follow-up to the seasonal forecast contracts that we have at present. Well, we need to discuss. I think the idea is to try and understand the capabilities of the systems that will upgrade in this year. I think we should, and we've discussed in the past, that you should prepare things to be ready to do this. I think it's foolish to throw a lot of computing resources at it before we know that there is any skill. So I think we need to strike the right balance there. In addition to that, And again, that's something you've been asking many times. Thankfully, now things are so close that I can't give you any details without having to shoot you afterwards. The invitation to tender for Decadal Prediction Service, it's coming up this summer. We've now had some good news about the budget, which has been increased, and you will have to watch the space. I will make sure that you're not all on holiday while this thing is open. That's it. Thank you very much.
Thank you, Anka. Thanks, Anka. Can you hear me? Yes. So thank you very much, Anka. In the interest of time, we will save the questions for the panel at the end of the session. I didn't remember for those listening to and watching to us online that you can leave your questions on Slido with the hashtag C3SGA. Our next speaker, I want to welcome him to the stage, is Chris Goddard. He also works as a scientist at the Weather and Climate Products team at ECMWF. And we will be now moving in timescales to climate projections, and he will be giving you an update on what's coming next. Thank you.
Thank you, Edu. Can everyone hear me? Yes, seeing nods, so that's good. Yeah, so I'm going to talk a bit about climate projections and how we aim to enable downstream services. So firstly, I'll start by obviously thanking my colleagues, and especially Andras, who is actually the technical officer for the contracts via which we procure these climate projections data. We both work in Anka's team, and I also need to thank, of course, the contractors who actually do the work, and the CDS team who make this data available via the CDS. So I'll skip the overview and go straight to the data. So far in this GA, we've heard a lot about reanalysis. We've heard about observations, so where we're looking about specific days, months, or years in the past. And now Anka's just spoken about seasonal and decadal predictions, where we're looking into the future. So for projections, it's a little different. What we're doing is aiming to enable users to look at plausible climate outcomes in the future for different areas they're interested in, regarding timescales, variables, etc. I'm not going to go through the whole range of data that's available on the CDS, and just invite you to go ahead and explore that yourselves. And this data is separated into global climate projections as well as regional climate projections, where those global projections are used to downscale dynamically the information to look at finer scales and enable things like impact models and other applications to be looked at where this finer scale detail is important. We also heard yesterday a couple of examples of using climate projections. So we heard about an attribution service, which is based in CMIP data, and we also heard from Wim about creating very powerful outreach based on climate projections data. So we've already seen some examples of how these data are used and can be powerful for users. So in terms of the strategy at C3S, we're aiming to build on those data, which all come from the World Climate Research Program, I should have mentioned, and these are made available via ESGF. So this data is already in the public domain, but what we aim to do is build an operational service on top of those research mode activities by collaborating with European ESGF nodes. So here we aim to provide a broad range of quality control data which are relevant to climate services. So that then acts as a sub-selection of that broad range of data that's available on ESGF. So for example, from CMIP6, I think there's more than 10 petabytes of data available on ESGF. And from that, we make a big sub-selection of the most relevant data which we want to provide to our climate services users. So the final aspect is about user-friendly data selection. So while those in the climate modeling community may be very familiar with the SGF and the various complexities of the data, that's not necessarily the case for the whole range of users. So C3S here, we're not competing with the SGF. I think we're supplementing it by talking to a broader range of users and simplifying the process for them in a variety of ways. One of those ways we're doing that is via the C3S Atlas, which has already been mentioned yesterday and in previous GAs, so I won't dwell on it too much, just to mention that Jose and Danny will be there this evening to give a demo of this, and also refer you to various documentation online which we have. And in terms of a strategy, this is really the graphical entry point to the data made available by C3S, including climate projections. I say including because we also have reanalysis and observations which are made available there. So the underpinning data, so that's a graphical entry point which doesn't require users to interact programmatically with the data. But we also have the underpinning data which we're making available for users to develop downstream applications and services. I've said coming soon on this slide, but actually, following Angel's announcement yesterday of the C3S, the new CDS beta, this data is actually available there for the first time. So I invite you to go ahead and take up Angel's call to action and go and look at the data yourselves. And this is adding value to users in that there's a reduced data volume, there's monthly aggregations which are already available, and pre-calculated indices which aren't directly available in other ways, so it saves users a lot of computational effort and expertise and gives them easy access to this data on a common set of nested grids, so that aids into comparison between, say, reanalysis and projections. Just the last piece of the puzzle here in terms of the C3S offering on climate projections is derived data sets and sectoral applications. So this is work led by Chiara as part of the sectoral information system. And here, those climate projections data that C3S make available are used in various different contexts and different use cases to develop downstream data and applications which are valuable to users. And the way this fits in is that in different cases, different data sets, different elements of the climate projection data set are going to be relevant. So there's going to be variation in which data is selected depending on the specific use case. And the atlas may be able to act as the first sort of filter and the first access point for users to explore the data before broadening it out into the full set of data available. So in terms of added value beyond the climate data that's already available via WCRP. So this is the same data, but it's about support for a range of users. So I list there various ways in which we're adding value for users. And I think one of the main things is really the user questions and requirements. So there's active user support. So I was reminded yesterday when we talked about education being an important use case that recently me and Andras had a user question where someone at a university was setting up some kind of tutorial for students, and they wanted to know about the sea level rise data that we make available, for example. So I think this is a really valuable element of the C3S offering on projections, is that user support and the way the requirements can then feed back through the value chain. Some of them we meet ourselves as C3S, but some of them we feed back into the climate projections community at large. Another two key aspects are quality control, both pre-publication and post-publication. So I'll briefly speak about both of those elements. So climate projections data, which is made available on the ESGF, is subject to a pre-publication workflow, which includes quality control, but there are various ways that that can be circumvented depending on the timescales involved and if things are being rushed, but also that things may just slip through. So at C3S, what we're aiming to do is apply an additional rigorous quality control which filters this data and makes sure that all the data we're making available is subject to these high standards. And we also document these procedures, the checks and the results. And this data we then make available interacts with the users as well as with the EQC function, and this all works to strengthen our data and our service provision. The other element is the post-publication evaluation and quality control that Zheng Shui has mentioned yesterday in terms of her poster. So this is an additional element that builds on top of the available data and adds value to users by providing quality assurance. So that's the kind of basic checks which let you know the data is adhering to certain standards. Then we have quality assessments where they're really evaluations of the actual data content. So they're answering scientific questions in the context of a specific use case. So this is adding examples for users and best practice that they can follow in some cases. And the aim is to aid users in making fitness for purpose judgments themselves. So it's not about telling users exactly what data they should use for a given purpose, but it's about empowering the users to make that decision themselves. I think back to Hans's analogy about the oat milk in the supermarket, and in this case, it's not about telling the users which oat milk to take, it's about letting them make that decision themselves. So another element I was going to mention is how we are interacting with the climate science community. And next we're going to hear from Helene on plans for CMIP7. So C3S has supported the climate prediction and projection, in this case, community in various ways so far. I'm not going to list them all, but just mention that part of my role is to be a liaison officer with the CMIP International Project Office, and that's another way that we are able to provide additional support to the community. Currently, the focus is on aspects of operationalization. That's a loaded term, and I'll let Paco deal with exactly what that might mean for climate projections later. But another aspect is, where that's quite clear, is forcings and making them regular and sustained. So in collaboration with the IPO, we will be supporting a forcings workshop later this year, working towards this end. So I'll close on our future plans. So in the near term, there's going to be an update to the CMIP6 data offering from C3S. So this is going to be following an updated data selection and QC procedure, which will mean we can add more data. There's also going to be synchronization with updates at ESGF in a more regular manner, which means things that change in the ESGF archive are then going to be reflected in the data provided from C3S, and additional web processing services, which again are aiding users in the use of the data. We're also going to look at publishing the CMIP6 downscaled Codex simulations as they become available and a critical mass is ready for publication. And these things will all feed into the Climate Atlas. So over time, this atlas, which is now operational, it's going to have additional functionalities, but also the underpinning data will be updated as more indices are requested by users or as more data is available to add. And in the longer term, we're thinking about statistical and machine learning downscaling to enhance regional climate projections data sets. So we heard from Andras earlier about that in the context of reanalysis. And here we're talking about climate projections and filling in some of the uncertainty space that's inherent in having these downscaled regional projections. We're thinking about how we can have more tools and applications which support climate service users, and of course thinking about CMIP7 data. And Liam will be speaking about that next. Okay, thank you.
I think we have time for that. Yeah, thank you very much. Thanks for keeping in time. I think we have time if there's any quick clarification question for Chris about his talk. If not, we can move and leave the questions for the panel discussion. Any questions? So thank you very much, Chris. Our next speaker is online. She's Helene Hewitt from the Met Office. She's also co-chair of the CMIP panel, and she's a science fellow at the UK Met Office Hadley Centre. I hope you can hear us, Helene. Are you there?
Yeah, absolutely.
Good. And she will be talking to us today about the plans for CMIP7 in, as the title precisely says, supporting the climate community. The floor is yours, Helene.
Okay, so thank you so much for this invitation to talk, and I'm really sorry that I can't be with you in person. As you heard, I'm the co-chair, along with John Dunn from GFDL of CMIP, and I'm going to talk to you about this latest phase in CMIP and how we're moving to supporting both climate science and services. And I hope that you can hear me fine. Okay, so next slide. So CMIP is often thought as being IPCC. It's not IPCC. It is a project of the World Climate Research Programme, but it does support climate services, including IPCC. So there are key elements of CMIP that support services. These are the benchmarking of models through standard experiments, the provision of historical forcings and also future scenarios, and making CMIP data widely available. CMIP also supports climate science, and this includes coordination of model intercomparison projects, which answer science questions, and critically, the infrastructure which facilitates these projects. So next slide. And the next one. So how did we get from CMIP 6 to CMIP 7? So CMIP has evolved through various phases, from CMIP 3, shown here in green, to CMIP 5 in blue and CMIP 6 in red. And as we've evolved through these phases, we see both the participation in CMIP increasing and the level of detailed process representation in the models increasing. CMIP 6, you can see from these statistics, was a huge endeavour by the climate modelling centres around the world and the science community at large. There are many modelling to comparison projects, many institutions, many models, many experiments which took place. The legacy is the nearly 25 petabytes of data which is available and hosted around the world. And that really supports many climate research projects. Next slide. So at the end of CMIP 6, the WCRP decided to have a CMIP International Project Office. We're very lucky that that is hosted by ESA, and we're also delighted to have extra support from C3S and Chris's role. After CMIP 6, the IPO ran a survey to gain community feedback, and I won't describe this in detail, you can read it at your leisure, but I'll just highlight a couple of key points. First of all, people wanted to keep the structure of CMIP 6, but evolve it. But what they did want to see was a reduced burden on the modelling centres. Respondents really highlighted the need for new scenarios and also this move towards operationalization of key elements of CMIP, which Chris has also talked about. And also there was a mood to really widen the CMIP community to scientists across the globe and much earlier in their careers. So I hope you'll see that we've really tried hard as a CMIP panel to address these points. So next slide. So following the survey, the CMIP panel did actually ask ourselves whether we needed a new phase of CMIP. So we looked at the continuing need for multi-model ensembles, particularly in the context of the WCRP science objectives. And we agreed that there was this continuing scientific need and demand. So there are 4 objectives. We see that CMIP is continuing to contribute to the fundamental understanding of the climate system, for example, reconciling observations with models which have higher climate sensitivity. Looking on the near-term evolution, CMIP models include the complexity to look at the uncertainty in aerosol forcing. Looking on longer time scales, CMIP has a really important role looking at this long-term response of the climate system, including tipping points. And of course, in terms of bridging climate science and society, CMIP plays an important role in IPCC assessments, as well as providing the data to C3S users and others. In IPCC, as the scenarios and the science questions evolve, CMIP continues to be relevant. And it's also really important for enabling Cordex to provide the downscaling projections to have those more detailed projections in particular regions. So next slide. So we've done a couple of things in CMIP. First of all, we've evolved the structure, so the governance, if you like. So we now have like a perhaps more open, transparent structure with many more people involved. We have 8 task teams which are working on various aspects of the design of CMIP 7. We're clearly linked to the scenario development, the impacts and adaptation community. And I think through lots of surveys and interaction, we've really strengthened our communication with people working on the provision of CMIP, from the forcing dataset providers to modelling centres to the Earth System Grid Federation, where the CMIP data is hosted. And we've really worked hard as well to promote a much stronger dialogue with funders and the service providers, such as IPCC, but many others as well. So next slide. So critically, we've evolved the design of the CMIP experiments. as we move into this next phase. And this is really based on the feedback from the modelling centres and the user community. So in our vision, we envisage CMIP as moving towards a more continuous approach. You see at the centre of this figure, we have the deck. This is a set of experiments which allow all centres to benchmark their climate models, and it's like the entry card to CMIP. In CMIP 7, we will also make it mandatory for modelling centres to provide documentation with those models. This will be the essential model documentation, which Chris spoke about. And this has been designed to keep the burden on the modelling centres low in terms of documentation, but to provide all that is necessary for the users. So in this figure, you'll see to the right, the community model into comparison projects. We see these as addressing science questions on the timescale that is appropriate for those projects. We also, to have the more targeted approach for particular activities, we have the fast track experiments shown in yellow here. And these are for specific purposes. The first fast track is being designed to meet the needs of IPCC AR7. And all of these experiments are supported by the CMIP infrastructure, standards, and the tools. And alongside this on your left, you will see that we're moving towards a more continuous update of forcings, which I will say some more about. So the next slide. So what do we have in the experiment sets? So as I said, the deck comprises standard experiments for benchmarking, forced atmosphere model experiments, control experiments to quantify variability and drift, that idealize changes in carbon dioxide to quantify climate sensitivity. And we've also included in that set now historical simulations which utilize the updated forcings. The fast track, on the other hand, is directed towards the anticipated needs of AR7, but of course has a much broader interest in the community. We've tried to split this into what we see as climate services experiments. So this is the decadal predictions and longer term projections under a range of scenarios. But it also includes process understanding experiments, which are related to those service needs. So, for example, one of the flagship aspects of the projections in CMIP 7 will be that the models will be forced by their greenhouse gas emissions rather than concentrations. So some of those process understanding experiments will be focused on understanding the role of the carbon cycle and the uncertainty there. And this will be critical to understanding how the uncertainty has changed under emissions rather than concentrations. So next slide. So the timeline, of course, for delivering the fast track is critical and what we're often asked about. As many people may know, the dates for the IPCC AR7 reports have yet to be decided. So these are shown in the dashed box at the top. We have worked with the modelling centres in spite of this uncertainty to produce a timeline that we think will work. So we anticipate the fast track starting in the middle of next year and delivering many of the results by the end of 2026. That timeline will then enable impact studies, Cordex downscaling, and critically for sea level projections, the ECMWF 7 even projections of the future evolution of the ice sheets. Prior to the fast track starting, we have much work underway, developing the historical forcings and the scenarios, in addition to updating the CMIP infrastructure. And I'll give you a quick update on both of these aspects. So next slide, and again. So the forcings is one of the 8 areas where we have a CMIP 7 task team working. So CMIP 7 will update the historical forcings, and in some cases, move to new and improved data sets. So the plan is that pre-testing versions of the updated data sets will be made available soon. And then they will be for wider use next year for the historical experiments. We have a special issue already open in geoscientific model development, which will be available for documentation of the forcings data sets. Next slide. And what this slide illustrates is the many components that go into the historical forcings, from CO2 emissions to land use, ozone and sulfate aerosol emissions from volcanoes. You can see here that we have a fairly detailed plan of when updates to the forcings, when extensions will be available, when new time series will be available. And as Chris also said, to continue the work to not just an update for CMIP7, but to move towards a more continuous update, we have a workshop planned in late October, which we're very grateful to C3S for some support, and that will be held at ECMWF. So next slide. So obviously a really critical part to the service is the projections of future climate. This is important for the climate negotiations, for mitigation, for impacts assessments, for the adaptation planning. And the scenarios allow the exploration of climate consequences of set drivers of climate change over plausible values. And this covers a wide range of possible outcomes, as illustrated here in the surface temperature projections from CMIP6 and used in IPCC AR6. So next slide. So the new scenarios for CMIP7 are being designed. We've had a group in Scenario MIP working on this. It's been open for community review. So as I've already mentioned, a key change will be that they will prescribe emissions rather than concentrations. Although having said that, some models will still be able to have a concentration version to run. The plan is that these scenarios will span a range of possible outcomes. The high emissions will be closer to 7 watts per meter squared rather than the 8.5 watts per meter squared we saw in CMIP6 and AR6. There will be medium emissions close to the current commitments, and then several low emissions pathways, which will also include overshooting of 1.5 degrees. So the plan from now is that this broad design will be developed with the integrated assessment modelling community. Forcings for climate models will be produced, and critically, these will need to be harmonised with historical forcings before climate models can run with these new scenarios as part of the fast track experiments. So next slide. And turning to data provision. So firstly, the data request. So we have worked to develop variables that we will require climate models to produce at 3 levels. The first is what's called the core level. These will be variables that are essential for all climate models. Perhaps you might think of these as a little like the model equivalent of the GCOS essential climate variables. We will have a harmonized set of variable requirements, which we are looking across thematic areas for, and this will lead to a consolidated request for the fast track. And on a longer timeline, we will allow the modeling to comparison projects to have the flexibility to include additional variables, which are specific to their scientific needs. So next slide. And finally, a key component to CMIP, as Chris also talked about, is the open accessibility of the data. So this is provided by the Earth System Grid Federation. And as you can see here, there are many components, both to ESGF, but also the variable definitions that underpin this. And the CMIP IPO and the CMIP panel are working with the ESGF community to ensure that delivery and timelines are well aligned. ESGF is already funded in the US by DOE, while the funding is less clear in Europe at the moment. So there's much work to do there as well. So next slide. So to wrap up, I hope that what you see is that CMIP has evolved in its governance, its culture, and its design. We've an incredibly open and transparent process. We've seen a huge enthusiasm across the community. And notably, we launched this an early career effort, which we call Fresh Eyes on CMIP. And we now have over 100 early career researchers contributing to the CMIP efforts, but we very much hope at the same time developing their skills. So I hope that you see that we're moving towards a place where we're defining more clearly the science and service applications as more distinct, both benefiting from the infrastructure, but giving more freedom for the science timelines. We see this demand for more routine delivery of critical CMIP activities, the forcings, the scenarios, regular projections, and benchmarking. And so to this end, we are starting an exercise to scope a regular, sustained mode for some of these aspects of CMIP as we move beyond CMIP 7. And finally, I just leave you with one last slide. And that's that, CMIP really sits in a multiverse of models and emulators. And, it spans or fits into this multiverse of resolution, complexity, and ensembles, where CMIP really provides the multi-model ensembles and the representation of complexer system processes. And we hope this complements efforts on kilometre scale modelling. We have a high resolution modelling to comparison project, and we've worked within that in the protocol that we're going to propose to try and provide a traceability across some of the resolutions. And so with that, I hope you're inspired by what we're trying to achieve in CMIP 7, and happy to take questions now or at the end.
Thank you very much, Helene. Thanks a lot for a very clear introduction in what are the plans for CMIP. As I said before, we are a bit behind the schedule, so in the interest of time, we will move the questions to the panel. And our final speaker for this afternoon session, it's Paco Dobles Reyes. He's the director of the Earth Science Department of the Barcelona Supercomputing Center, and he's also a coordinator lead author in the last IPCC report, the 6th assessment report from IPCC, and he has also been working as a lead author in the previous reports. And he will be talking about one of the challenges we have ahead, and it's not only about pronouncing the word operationalization, but also about actually implementing it. So I give the floor to Paco.
Okay. Thank you. Thanks, Edu, and thanks to the organizers for this opportunity to speak. It's very nice to speak after Helene, because she has done a lot of the work that I had to do. So what I'm going to talk here is not about C3S, but about trying to think a bit out of the box and see how we can really build on the massive amount of knowledge that is in the science community to develop climate services based on climate projections that are a bit more sustainable and robust in the future. So, sorry, I changed the title of my presentation to make justice to what I'm going to talk about, and also I apologize to those that have heard this presentation already last week. Let me start with an image that I think will help a bit to understand what the main thread of the presentation is. And I'll go back to these photos at the end of the presentation. So the one on the left is a production chain of a Mercedes factory, and this production chain is doing production. Everything that they are doing is reproducible, is traceable, based on market study. At times they get it wrong, but judging from the amount of money they're making, it's not very often. They also have very strict quality control and standards, pretty much like C3S, probably stricter. And the production is scheduled because everyone wants to get the car when they were told that the car will arrive at the place where they're buying it. And there are many other characteristics that are specific to a production chain. On the right, you have a very nice concept car, also from Mercedes. It's a one-off. It was produced in 2017. It's not necessarily reproducible. It was done based on real drive by people who love cars. It's market independent, so it's done to explore things, and it's not necessarily related to standards. It's basically exploratory. It's equivalent to what research would be. And as I said before, I'll go back to these images later. The climate information is now widespread. It's been used in many different environments. The private sector is really been very present in the use of climate information. That is using climate projections and many other sources of information. But also countries are using climate information from climate projections from the research community. And Switzerland is an example. There are many more. The European Environment Agency is another key actor that has been making use of climate projections to make really important decisions for European citizens. And if we go even global, we are familiar with the IPCC reports and the use of this information in the COP negotiations. So the climate projections that Helene was talking about, which are fundamental for understanding how the climate system works, they are being used downstream in a very large variety of environments and for decision making. This is mainly related to policy making, and there are many more uses that have been illustrated widely by C3S. So climate information is basically the result of a very complex process that uses knowledge, data, literature, and observations from everywhere that we can get it, and brings together many different actors that appear on the left, the users of this information, the producers of the information, and actually the scientists that are underpinning the knowledge that is behind this production. I've been accused by the philosophers in my department that the figure on the right, which is from the IPCC, it's actually not making justice with the way climate information is produced, because the climate information should be produced, if possible, starting from the question. And the question is actually coming from the decision making and makers and the users. But it was done by scientists, and that's a bias in that figure. It's just one of the biases that we have. What are the sources of the climate information for climate projections? Well, there are two main sources. One of them has been presented by Helene. They are absolutely fundamental, and hopefully they'll continue in the future. They are key elements in everything that has to do with climate change, for adaptation, mitigation, disaster risk recovery, and risk assessments. The really important factor here is that there are many actors that intervene, but it's mainly research-driven. Research-driven, research-funded, research-driven, researchers doing the work. It's something similar happening with Cordex. It's even harder in Cordex. There are lots of models that are being run by institutions that are struggling to produce these kind of simulations that are fundamental to make decisions. Research-driven, again. So what is the alternative? So is there anything else that we can do that goes beyond these research environments for producing the climate projection data? So yes, the WMO has an infrastructure that is designed for the operationalization, for producing information that is not just relevant for the national Met services that are producing this information for their citizens, but for all the other countries of the WMO system that don't have the capabilities of producing this data and the corresponding information. And it's absolutely essential that countries keep supporting this system. I see Petteri, who is in the room, and I guess that he won't disagree with me. Good. But the important thing is that WIPS, which is, I'll go back, is the WMO Integrated Processing and Prediction System, which encompasses all the rules and guidelines and all the ways of producing this kind of data, has a lot of activities, plenty. Hydrology, weather forecasting observations, climate predictions for seasonal, from subseasonal to decadal, but nothing on climate projections. Zero activities on climate projections at the WMO level in operational sense. And this is not good, because somehow we have a very strong research component that struggles to really continue with their work, and they really work very hard to do what they do. On the other side, we have the WMO system that has not been called in to support the operational aspects of the climate projections. Can this be done? Can research be transferred to the WMO system? Yes, it can. And an example, and out of many, is a recent move of the decadal predictions into an operational activity. So there is still a research component, a decadal prediction, but there is now an operational activity of at WMO level that is producing decadal prediction information that is disseminated globally. And it's done every year. There is a commitment of every country that is part of this system to make those predictions and issue these reports. There are also some guidelines that are being produced as we speak by one of the committees of WMO that is developing guidelines for the use and interpretation of the climate projections, but it's nothing yet in terms of how the projections, how the data is going to be generated, because this is a really expensive part. It's very, very expensive. The call for operationalizing the production of climate projections has been already out in the community. There are papers already that have made very clear that there are demands that cannot be satisfied currently by CMIP and Cordex, because, as Helene said, CMIP is underpinning the efforts behind the IPCC assessment reports, and is especially focusing on supporting the scientific questions that are behind the changes in the climate system. And it's a very strong and very hard commitment. So we need to really recognize that there are requirements that are coming from different negotiations that are taking place at the COP, and that are actually making the need of generating new sources of climate projection data. Helene presented some of the things that are changing. So AR7 is having a fast track that is making the information, the climate projections accessible much earlier. But I would like to emphasize the time that she spent talking about the historical forcings and the production of these scenarios. This is done, those scenarios and forcings are done by a handful of people around the world that are doing this work using research grants. So the whole scene about the scenario MIP is supported on the goodwill of a lot of researchers that are making their best. And we can't really continue this way. We have to really support this in an operational way. There are other things that are, other aspects that are moving, like, for instance, the use of emulators, basically because we have no way to run the models with more frequent cycles. And this is an example from the PROVIDE project that is supporting policy making by considering different scenarios that are not part of the CMIP exercise. Another example is from Destination Earth. So this is a new initiative from the European Commission that is also managed by ECMWF along with EUMETSAT and ESA, that is developing infrastructures to make these kind of simulations much faster and taking into account the kind of technical challenges that we are confronting if we need to do these projections in an operational context. I'll jump this and go straight back to the images. So the image on the left, the production chain, is actually what I think we need to make operational climate projections to timely respond to new demands from policymakers and society at large. And those demands are at times not even emerging because the imagination of those that need them can't really even think or conceive that it's possible to rerun the models given the resources necessary to do this kind of thing. The one on the right won't disappear. Concept cars are absolutely essential if we want to make progress with the way we are addressing mobility at the global scale. And the two together is what really makes a sustainable business. And that this is my point here. So these demands that are emerging for more frequent and targeted climate change projections actually require an operationalization step that needs to be discussed very largely in the community, and that is supported by an equally strong research component. And it's not very different to some of the initiatives that CIMIP is already discussing within itself. The identification of these operational components is something that it's still to be, it needs a lot of discussion, but what we need to realize is that we cannot just rely on the goodwill and effort of a lot of researchers that are making their best to support really important decisions at the global scale. Thank you very much.
You can stay. Yeah. Thank you very much, Paco. Thanks. I think you might think that I have been terrible in timekeeping because it's only 5 minutes left till the end of this session. But I have to remind you that we have started some 9 minutes late. So I think 5 plus 9, it gives us around 40 minutes for a panel discussion, even though that will mean that we will delay the next session. So if we can have some chairs for our speakers, I don't know where they are or how this works. Okay.
Okay.
Yep. And Helen, I guess you are also around in case there are some questions for you. Yeah, so she's around, okay. Good, I've been checking at Slido. We don't have any question from the online audience. So I would like to invite you to ask any questions at the audience here at the venue. Do you have any questions in the room? Okay. So we have all of them? Yep. Gil, can we?
First, thank you for the presentations. The IPCC, the CIMIP 7 and Paco was very perfect together. Paco, we know that there is like a boost and a bubble around the use of climate data for instance, people like Deloitte, yeah, that represents how this data is used in a way that probably you don't want to know how it's used. With these two strategies, there won't be like a competition between CIMIP 7 and more flashy and spectacular data that is updated more often, that has more high resolution. At the end, the people, the industry will use this high resolution or with other positive value, no? But that they don't represent, for instance, uncertainty or other aspects of the climate components. It's a risk that I want to ask.
Well, I think that has to do with my other life, which is climate services standards and quality control. So I guess that what we need for the private sector and all those actors in the market that are really delivering climate information as a product are proper standards that they have to comply to, and that's something that now with the new compliance with the taxonomy that all the companies have to do and take into account is more necessary than ever. C3S will comply very quickly with any standards that are formulated, but then the private sector, these flashy products that are being out there, they might have to also, I don't know, for instance, ensure that they're transparent. It's something that with Harry Laus we have discussed. No? Transparency is fundamental, when a product that is being delivered to the market, which has some life-threatening components, or some, it could be understood that way, is delivered. And so far, there are no standards for this. So there are no standards for climate services. In what way that competes or I don't know, affects CMIP7, I think CMIP7 has its own life, and I don't see CMIP7 being affected by these kind of things. But Helene is she knows much better than me.
Thank you.
Well, I don't know if Helene wants to add something to what Paco just said. We cannot see her now, so we don't know if it. If not, we can move to the next question. Yeah, she's here.
Oh gosh. Okay, so I better say something good, being that large on the screen. So I, just wanted to emphasise I think what Paco said is exactly right, and I think in CMIP, particularly through CMIP7, we're really recognising that we really need to support this service need. That we need to operationalise the forcing so they're updated. I think we prefer the term regular sustained mode rather than operational, which, we're not talking about a weather forecast here. It doesn't need to be supported 24/7, but it does need to be regular, and it does critically need sustained funding. And that's at the crux of this. We're not going to be able to have regular forcings. We're not going to be able to have more regular updates on scenarios and projections unless we have sustained funding. And I don't see a problem with the rest of the community. I think we work together. I hope that it will include multi-model ensembles with complex processes going out for many years, as well as higher resolution models, which are on, a multi-year, decadal timeline. And I think it just is a call to us all to work together to enable this.
Yep, thank you. Thank you very much. Do we have any other questions? Yes, at the back of the room. And
Mark Payne from the Danish Meteorological Institute. I was very both in awe and shocked by the speed at which CMIP7 is aiming to be turned around in. And I can see it potentially creates a problem for the adaptation community. Adaptation in Europe and many parts of the world is driven by Cordex data, which is a downstream product of CMIP. And the real risk, as Paco sort of highlighted, is that Cordex gets even further left behind. Is there any thought being given to how we take that next step to not only operationalize the global projections, but also the regional projections?
Yep, okay. I guess we need the Helene again in the screen. Now, this also explains the clustering setup in the chairs, so we can see her in the middle. I hope. Well,
Yeah.
even if we don't have the image, I think we can hear you, can we?
Okay, good.
Yep.
Great. So Cordex, absolutely. When we started off with CMIP7, our ambition really was that it would go very seamlessly through to Cordex. I think that is too much of an ambition on this timeline, and we perhaps need to think harder about how to do that. We are, however, working with the ice sheet modelling community, and they are very keen to turn it round quickly for ISMIP7. So I think it is possible, but when I've spoken with the Cordex community, there's lots of work that goes on in assessing exactly which models you want for which area. And so I think we'd need to have all that. That would all need to be operationalised. So this is a big ask, and maybe this is where we also need the very high resolution models as well on a global scale. So there is much to be thought about, but we really want within CMIP to have this scoping exercise, which is transparent, which is open to the community, so lots of people can contribute their thoughts.
Edu, can I?
Yes, sure.
So I'd like to be very politically incorrect now, and there is a way forward, which is operationalizing very high-resolution global models. Then you have all the regions all together, and yeah, why not? It's running at 5 kilometers, a global model, now it's possible.
Yeah. Yes, Anke, please.
What plans do Codex have for using machine learning techniques for downscaling instead of dynamical models? Do we know? That might be another way to produce fast turnaround. We have somebody there who might have an answer.
We can give the microphone.
So I'm José Manuel Gutiérrez from Spain. I'm part of Cordex SAT. And we actually have plans for doing a number of things, including machine learning, of course, but not only, and to increase the coordination with the CMIP to create the boundary conditions to do the downscaling in a quick process. So we just started a number of task forces that all contribute to that particular mission, which is to better engage with CMIP and with other communities like machine learning to produce in a time reasonable projections aligned with, in this case, CMIP7. Thank you.
Thanks, José Manuel. Yeah, well, it's nice how this is truly a discussion panel where not only the questions come in one direction. So we also had we had before one question from Shunshue and then Stefano. Here.
Thank you very much for all the presentations. Really exciting to see the CMIP7, and I saw there are more than 130 models, and also the increase of ENSAMO members, double the ENSAMO members, and also operation of the high-resolution models. So I always bothers me is the data volume, because all these improvement, resolution, ENSAMO size will increase the data volume. I would like to hear your opinions how we can handle this huge amount of data set. Thank you so much.
Any takers?
I can start. Well, it's not necessarily about volume. I think the climate projections and climate predictions, the climate models, the coupled models, provide information not in the data itself. So I think developing the models to extract the information is important. Putting the tools next to the model data to try to process that is also important. I think Harry Lauers got to that point earlier when he asked the question of whether you really want to do downscaling. You think you have much more than the 1 degree resolution that the seasonal forecasts from C3S provide. I was not convinced by the answer. I think the answer is still to be found out there. So I think trying to work somewhat differently from just taking all the data, repeating the same process, labor-intensive process on all the data needs to be done.
Anyway, yes, Chris, please.
Well, so I didn't elaborate too much, but on my slides I did mention that one of the things we build on top of the ESGF infrastructure is that we have a web processing service running for our projections data, which means that users can do things like select a specific region they're interested in, or in time they can make subselections which aren't possible via ESGF, and these kind of things also aid users in really only getting the data that they need. And the Atlas is also another step in this direction.
Thank you, Chris. And we have it was Steph. We have 2 minutes for if the questions are quick. Do you want? If there is time, I will ask. Okay, so let's. Yeah. Okay, let's try to do 2 quick questions, Stefano, and then Lorian, and then we finish.
I just had this idea. I mean, have we really scratched the bottom of the barrel to improve the quality of seasonal forecasts of classical ECVs like C2 meters and precipitation? Or could AI, for example, by tackling the problem of signal-to-noise ratio, help us in reaching better performance before the downscaling methods do whatever they have to do? Remember that if the starting point is bad, there is no downscaling which can correct an error if the error is through error. So I was wondering whether we can have a bit more of ambition along this direction.
Yeah, thanks, Stefano. I think Esteban can.
Thank you. Well, Making any statement on what can be done or not with AI is difficult because you may have an idea and 6 months later somebody can develop something. But I think work has been put on at different levels, and definitely I think that some works have been done on how we can produce ensembles, on how we can assimilate data. I'm not familiar or not that familiar with that part, but I think maybe it's one of the things that can help.
Do you want to add anything, Anka? Nope. Okay, good. Yeah.
I've been instructed to keep it short.
Okay. Lorian, please.
Can you hear me now?
Yes.
Okay, great. Yeah, my question was more for Anka and maybe Esteban. Sorry, Paco. But I was wondering actually how, with the changing climate, seasonal predictions are still useful when talking about temperature predictions. We tend to have these very dark red seasonal outlooks over the Mediterranean especially. So I would like to hear your views on that. So we've heard about how working on seamless to climate projections, from seasonal to climate projections, and how do you think knowledge on climate evolution over the last few decades can feed into the seasonal prediction aspect, like removing trends and things like that? I would like to hear your views on that. Thanks.
So a simple answer to that would be that the first order problem is with the way we define the products. We define products in the same way we defined them before. There were generic definitions that we used in research projects 20 years ago. So I think better investigation into better defined products to give people the essence of the information could go some way towards answering this. However, do we know that red maps throughout are bad things? Maybe some people, in order to make some decisions, need to know the full signal, whether it comes from climate change or climate variability. So I think it's a very useful point, but I think we need to look into how to solve it. I don't think it's anything we need to do differently with the models necessarily.
We have 20 seconds
if I may add a bit on that, I agree, it's useful information, but it's perhaps not related, as Anka said, with getting rid of that, but in which new products we may develop. We have had the discussion of the representativity of the forecast with sometimes in Metcalf. And okay, it's useful for the users to compare what we are expecting with just the most recent memory of 5 years in order for them to interpret, or should we develop a product on the number of nights with minimum temperatures above 20 degrees, or with surpassing 40 in some regions? Perhaps it's not more of a question of how to deal with the trend, but which new products may add value over that.
Okay, thank you very much. Thanks, Esteban. And I think with that we can wrap up. We can finish the session, so I can ask you to give a round of applause to all the speakers. And finally, to invite you, there will be, there are some posters about the topic. You will have time to interact with them, and I think we can move safely now to the next session.
Hello, can you hear me? Is the microphone working? Well, if you have taken part to the General Assembly of C3S before, you know that we used to have this very professional moderator for the session. We don't have it this year, which means that I don't have any trick for you to keep you awake. But we have put something to help keeping the audience awake, which are, as Steve noticed, this chair. These are anti-sleep chairs. They are so uncomfortable that you cannot really relax. Which means that maybe we can give ourselves 1 minute to stretch our legs. So stand up, please. Good. You can relax a bit your lower back before we start, and then we'll have some more entertainment before the coffee break and the coffees. You good? Energy back? Excellent. So we can restart. Well, let's keep it nice and short. Huh? As I said, I'm not a professional moderator, so I don't have any trick for you. Good. So, for those of you who were here last week, actually last week, is the microphone on? Is working? Fine, good. For those of you who were here last week here at the same museum where we will be going at 7 o'clock for some drinks, we had the celebration of 10 years anniversary of Copernicus ECMWF. This is an important milestone. So we got the commission on the first day here talking about how important Copernicus is. We got the Secretary General of the United Nations talking about C3S. But this started 10 years ago when the commission decided to entrust ECMWF with the running of this service. It started with visionary people within the commission and within ECMWF. But he also started with the member states of ECMWF accepting this challenge. And this wasn't obvious, and I think was a brave move at that time. And somehow I would like to take stock of these 10 years today and reflect a bit on it. So for that reason, maybe you don't know, but tomorrow here in Brussels, also taking advantage of the Belgian presidency of the Commission, we will have the ECMWF Council. It means that the member state will come here to Brussels, and the council will take place here in Brussels. For this reason, we invited our ECMWF member state to join us at the General Assembly this afternoon, and we invited Daniel Gelen, who's the director of the Royal Meteorological Institution of Belgium, and also the former president of ECMWF Council, to come here today with us and reflect a bit on this journey, because he was very much part of the council when this started. So Daniel, the floor is yours.
Thank you very much. Can you hear me? Okay. So thank you to come in Brussels, of course. Nevertheless, the weather is not there, but you are specialists in the weather, so you know it's not our fault at the Royal Meteorological Institute. So we are doing our best. But coming back to the topics of the session here, I think at first I have to tell you a few words about the center itself. In fact, the center is the result of an initiative of the European Commission in the year 60 or 70s. So it's a very long story. At that moment, they took some decision about a strategic domain where it was very important to be independent and to be able to take decisions alone with their own resource. And after some workshop, they found that meteorology, and in particular, the medium range forecasting was one of the critical topics. So they gave the initiative, and it's a cost action who took the relay to start the reflection and build something on the base of all the meteorological community at that moment. And of course, it was broader than the EU, because EU was at that moment very small. Don't remember, it was maybe 6 countries or maybe more, but very small. And the result of this cost action was to build an intergovernmental organization covering a big part of Europe and being totally independent from the political affair and all the problems, and only dealing with the meteorology and the objective to make medium-range forecasting, which was very important at that moment, because in the year 60 or 70, a forecast of 3 days was really good, but further it was not possible. So the center is at that moment built with the idea to be completely independent and only focusing on one target, like EUMETSAT for the support developing satellites for the meteorological application. So when the staff came more than 10 years ago with this project to be the action of the EU for some specific products, it was a very strange reaction in the council, because some were, the members were puzzled. Some of them were really afraid to lose a part of the impedance of the center, but most of the members were very interested, because it was also an opportunity to develop synergy between the task of the center, but also everything related to climate. So we had a lot of discussion, and I think that the staff of the center came several council to explain the targets and the strategy. And after a while, I think everybody was agreeing the Copernicus cooperation between EU and the center. And after now 10 years and the renewal of the mandate, I think the target is really reached. The Copernicus applications are in a stationary regime, I think, proving that the cooperation is very efficient, proving that the visibility of all the Copernicus hosted by the center were on the top, and certainly the target is really there. You produce a lot of product available freely for the community. You put together a lot of energy, and I think the result is one of the examples. But let's say it was not very easy for the staff, but the arguments were there to convince the member of the council. CAMS is in fact the follower, the natural follower of everything related to GMS, of MAC project. So the center had already a very long experience with this kind of product. In addition, when you are looking at the operational aspect, it's clear that the center was already producing the EFAS product for the operational flood alarm system and hosting a service for GRC. So the experience of the relation between the center and the EU was already for a part built. For C3S, it was not so easy because projections were not the task with the longer term of the center, but the ERA products was already available and was one of the most well-known products of the center in the scientific community. So there were a part of the activity available already to build the beginning of the C3S. So I think the target has been reached for the center, and now the users are there. And I think that C3S is one of the well-known products giving every month this picture of the whole temperature, the global temperature, and it has been followed recently by all the community, the media, and the scientists. Now, coming back to the national aspects, I think it's difficult to take broad conclusions because some countries were directly reacting to the availability of the C3S products. I am not going to give scores to the members of the center, but it's clear that Belgium was not the fastest in this journey, because it's also related to the national point of view and the governments. And it's only with the last government, and Thomas Dermin yesterday mentioned it, that we built at the level of the federal government some instruments, in particular the Belgium Climate Center, which is going to build links, synergies between the university, the federal institution, and all the community having a link with the climate change. And also the new Climate and Environmental Risk Assessment Center, another organ hosted by the Health Ministry. But these two organs are going to work together to develop the new climate services, which was something very important decided in 2009 during the third climate conference. So we start late, but in the meantime, BELSPO, you have there some picture of them, that's the Belgian Science Policy Office, continue to develop things like the Codex activity at the level of Belgium, and we develop specific scenarios with very high resolution on Belgium. They develop also the continuity of some satellite experiments like Probave to the follow-up of the vegetation, which is very important for all the community. And in a few years, I think it's 26, we will have Altius, a new satellite for the follow-up of the ozone and trace gases. So we were not inactive, although we are starting late and we don't want to miss the train. So I hope I keep your attention. Thank you. After all the slides with very complicated things there, I think it's maybe difficult to do it. Thank you very much.
Thank you very much, Daniel. Thank you for this speech, and thank you also for the courage in representation of Council and the Member State for having Copernicus and starting this adventure. We'd like now to touch on the other side of that equation, which are our directors. And in the program, you have seen Florian Peppenberger, who's our director of the Forecast and Service Department. But actually, we got a good deal out of our directors, and we have 2 directors at the price of 1. So Florian will be joined by Vincent Rieperk, who some of you may know may remember as a director of the CAM service, and has recently become director for the strategic relationship with the European Commission. So, Florian, maybe you start? Oh, Vincent, start. You start.
Hello? Can you hear me? Yes, yes. Thanks, Carlo. So, yes, it's the 10th anniversary of Copernicus implementation at ECMWF. You see that the festivities have started with last week, but don't worry, they are continuing tonight. So you'll have your share. So we'll share the time with Florian on this presentation. Seen from the inside, Daniel mentioned what happens from our council, our member state. From the inside, it's quite clear that Copernicus has shaped ECMWF and has shaped many of your organizations across Europe. But I wanted to start by indicating that maybe also ECMWF has helped shape Copernicus, and it's a paper from our great predecessors, Tony Hollingsworth, Pedro Viterbo, Adrian Simmons. We've been really instrumental in shaping up what was not yet named Copernicus at ECMWF, and basically the message resonates with what Steve English mentioned this morning. You remember this curve where in the early 2000s, the South Hemisphere and the North Hemisphere skill were catching up because of the great advance of data assimilation processes, and basically this paper is saying that with all the development in using observations since 1985, so a little after ECMWF was created, with the data simulation development, there is now untapped potential, so that was in 2002, to do more in terms of environmental monitoring. And maybe this paper contributed to help decision-making in Europe to come up with a very ambitious program. The scale of the program, I was shocked the first time I saw this slide from our colleagues of ESA. Copernicus is a space program, as you know. You know very well the meteorological satellite infrastructure that is orange, operated by our colleagues and friends of EUMETSAT. You see the polar orbiters, the METOPS, and you see the geostationary, the Meteosat. These are the satellites. You know very well also the programs of the European Space Agency in green, so that's mainly the Earth Explorers. EarthCare has been launched very recently, and we have a lineup of explorers up to the last that was selected, which is Earth Explorer 12. And in the middle, this zoo of different satellites that you see is Copernicus. So really, we were at the edge of a new era in terms of Earth observation. And what Copernicus does is to tap in this incredible new amount of information. But if you look at what makes Copernicus really unique, because our friends in North America, in Asia, they do have very good Earth observation satellites, and we've been using them a lot and relying them on a lot. But what many continents envy us in Europe is to have services. And to develop these services, Daniel mentioned this story. I will use the story of MAC, which in CAMS, which was taking the long road. So we started in 2004, so 20 years ago. You see all the logos of GMES evolving to Copernicus. Gradually, you see projects, you see meetings with users, the ingredient being research, discussing with stakeholders, discussing with users, And in a road of 10 years, we arrived at the point of having a Copernicus atmosphere monitoring service. In the case of the C3S colleagues, they are in the room actually. Jean-Noël, Bernard, Dick decided to take the steep road. So less years, but go to the same place. And same story, it was a big collection of building on a number of framework program and Horizon projects, which have contributed each bits of C3S that we see today. Also lots of engagement with the user, engagement with the member states to shape the program. And they managed to be on the rendezvous point in 2014, so 10 years ago. And that's where Florent takes over.
Thank you very much. 10 years, huh? Bloody hell. Honestly, I think any of us who have been there 10 years ago wouldn't have really seen this journey. Vincent really said some took the steep road, some took the long road. At the end, we all came to quite a success story. I think it's super impressive, huh? 112 entities involved, 25 countries in the EU and across ECMWF member and cooperating states, 2 international organizations, 2 third countries. Total value of signed framework agreements, 100 million, 10 years. I think it has been a success story, as the party is gonna go on tonight. And there you see how it was signed originally, actually. Of course, here mainly because of C3S, and C3S has delivered so much. It was really successful in these 10 years. It is super impressive, and I know Carlos is going to show some of that later. But if I just try to even show you on a single slide what C3S has achieved in these 10 years, I do it so much injustice. Maybe the European State of the Climate, maybe collaboration across the world, maybe user engagement and so forth. It has been such a long journey. It's a really thriving ecosystem, and it is very impressive what you all have achieved in this room. You're all part of this journey. You all have done this. Of course, what's next? I do believe that Copernicus has delivered for the European Weather Centre, and the European Weather Centre has delivered for Copernicus and the EU, as well as the ECMWF member and cooperating states. It has been a real working together. I don't think one would have worked without the other, and it's very impressive. This is what else do I have to say? We do know that sometimes maybe some more excessive language is used, like a boiling planet. However, it has been warm. And if you want to summarize the success of C3S, it's very simple. It has made a real impact in climate change science, in climate change, in communication, and providing useful data for real decision making, not just some simple research project. It was far more than that. Copernicus activities are now entirely embedded within ECMWF. We've really worked very hard of making them together, making it one, to deliver Copernicus. Its member states and contractors can build on a really extraordinary track record. 10 years of implementing Copernicus on behalf of the European Union. We are hugely grateful that the European Union and the European Commission had this vision 10 years ago or 12 years ago, or whatever, how far you want to go back to this. The EO revolution is really in progress, and I do believe you see the glimpse of where we're trying to push the boundaries even more. Copernicus is still pushing the boundaries, but you're going to have a presentation on Destination Earth by Irina just later. So I really would like to simply thank all of you for being part of this journey, for making ECMWF successful, for ECMWF being part of Copernicus, and for making Copernicus such a success. Thank you.
This plants a bit in the way, yeah, thank you, Florian, thank you, Vincent-Henri. That was splendid. Actually, in the interest of time, and also considering that during this General Assembly, I talked already a lot about C3S, and we heard so much about C3S. I'm not going to trumpet here the successes of the program. I think this has been actually said very strong and loud by our speakers throughout the day. What I would like to do is, because we like challenge at the ECMWF, we have seen challenges in the past and we have accepted those challenges, and we are moving forward with new challenges. So I would like to introduce Irina Sandu, who's leading on the Destination Earth initiative, to talk about the program and how the two programs interact with one another. Irina, the floor is yours.
Do I use this now? Thank you. Thanks a lot, Carlo, for the invitation, and Christina and others. And I think Carlo and I took the challenge because people always ask the question, how do Copernicus and Destination Earth complement each other? And then in particular, how C3S and Destination Earth complement each other. And basically, we have been discussing this quite a lot with Carlo, but also with Paco, and I'm going to show some of the slides Paco already showed. I think I went too fast. But first of all, for those of you who maybe don't know what Destination Earth is, it's a relatively new initiative of the European Commission, which started in December 21, so it's fairly new. It's only 2 years in compared to Copernicus, which is more than 10 years now. And it's implemented by ECMWF, ESA and EUMETSAT on behalf of the European Commission. And the aim is to build so-called digital twins of the Earth. And we know this is becoming a really trendy name. So what is Destination Earth actually doing? Destination Earth is aiming to build digital replicas of different aspects of the planet to respond and adapt to climate change and extreme events. And of course, it aims to complement what we already have, and we heard a lot of how much has been achieved in Copernicus, but there are also all the national services. So Destination Earth aims to build on past breakthroughs in science, technology, and on recent breakthroughs, in particular in supercomputing, with the Euro-HPC supercomputers, which are among the biggest in the world. And Destination Earth couldn't happen without LUMI, Leonardo, Mare Nostrum 5, or smaller systems like Meluxina, which are the three. LUMI, Leonardo, and Mare Nostrum 5 are three of the top 10 supercomputers in the world, the first pre-exaskills in Europe. But also on artificial intelligence and machine learning, as well as physical modeling, to really establish bespoke cutting-edge simulation capabilities, to give us a tool to simulate how the planet will evolve. But also to go to much higher resolutions, and Paco already alluded to that, to provide Earth system information at scales where many of the impacts of extreme events and climate change are felt, and that's kilometer scales globally. But it's also fostering an innovative and thriving EA-enabled digital ecosystem with the data lakes built by EUMETSAT close to the Euro-HPC and the core platform built by ESA, which will allow access to not only the digital twins, but also other existing data sets. So so of course we heard a lot about the success through the quiet revolution of numerical weather predictions, through the digital revolution of supercomputing, but also in all the environmental services as well. And we know the current systems allow us to do a lot of great things. However, there are still some limitations. In particular, there are limited resolutions. At global scale, the small scale processes cannot be represented fully. Of course, there is a sort of separation still between Earth system and impact sector models, where we have this cascade with Earth system models feeding the impact sector models. And there are also, what Paco spoke about already, limited ways to change experimental design or output, in particular for climate models, for climate projections. And there are predefined configurations and simulation runtimes, and we heard just before of CMIP and the 7 to 10 years cycles. And there is also a limited versatility to interact and access the data to some extent. So Destination Earth is aiming to build on this collective success, and it's really becoming a European endeavor. There are already 116 institutions involved formally in Destination Earth in more than 25 countries in Europe. And what it's aiming to do is really enhance on one side the resolutions, go to higher resolution globally, to provide high quality global information with local granularity. It's also aiming to operationalize, and Paco talked about that, create a framework to operationalize climate projections, to produce this type of information more regularly, but also on demand. And it's aiming to enhance the interactivity and to bring users closer to where the information is created through a co-design approach. So there are two digital twins you may have heard. There's a weather-induced extreme digital twin, which focuses on a few days ahead, both on meteorology but also on environmental extremes, which would allow to answer questions such as will a wind farm shut and what will happen to the energy production. This is implemented, I'll not go in details today because I wanted to focus on the climate twin, but this is implemented by ECMWF together with a lot of Met services throughout Europe. There are more than 20 Met services involved in delivering the regional component, and ECMWF is delivering the global component built on our integrated forecasting system. The second digital twin is the climate change adaptation digital twin that Paco mentioned. It's focusing on multi-decadal timescales, and it really allows to more think about where should we build the next wind farms, etc., given the circulation may change. This is implemented on behalf of, through a contract procured by ECMWF by a very strong consortium, and I think some of the leads are here in the room, Paco being one of them. It's led by the CSC Center in Finland with very important involvement from BSc, the Max Planck Institute, and the Alfred Wigner Institute, but many other institutions are involved as well. So Paco already showed this, so I'll go very fast, but the point is that current climate source, information sources for projections involve indeed many global models, involve ensembles, but they are research driven, they are happening in a research framework. They are resolutions globally of 50 to 150 kilometers, and there are many years, many updates between cycles, and there is a sort of static archive. We heard before Cordex as well, that's also research driven. It's also resolutions between 10 and 50 kilometers. There are many domains. The models that are used, of course, are not consistent across regions, and they also don't cover necessarily the entire globe. And there is this need to take care of of this information for climate projections and to operationalize the on-demand production of climate information. And I stole Paco's slide, but it was to make this link between what exists and what is the direction in which Destination Earth is going. So the climate DT is aiming to set up the modeling infrastructure to operationalize climate projections. And the idea is to allow us to not only do more regular updates as new science becomes available, but also to test the impact of certain events if we want, or scenarios, or policy decisions on multiple timescales. The simulations are at 5 kilometers through the atmosphere, land, ocean, and sea ice. And of course, they have a heavy price tag in terms of GPU hours, so it's not that every user can request such a simulation. But in the case where Europe would want to make such a run on demand, we have the capability to do it. And what is consisting of is really an entire workflow which was installed on LUMI in less than 1 year. We got access to the LUMI supercomputer in April last year, and we managed to do the first multi-decadal integrations from 2020 to 2040 with 2 of our 3 global climate models of 5 kilometer resolutions, which are the integrated forecasting system coupled with the ocean and FESOM ocean models and ICON. But we haven't done only the models which produce the beautiful movies created by BSc, but a really important point is that we created a common format and data governance structure, which is a so-called generic state vector, which allows that if you want to use this information at very high resolution on a new type of grid, this HILPIX grid, then you can use it, you can reuse this, you can very easily look at any new simulation which is coming. Importantly, it also builds in statistics, so-called one-pass algorithms, which allow to transfer the climate information in user-relative information, like, for example, in a nice example created by BSc, weekly PDFs of wind speed at 100 meters, something that today we don't dispose of for wind energy. It also has, similar to what we build in NWP, an online monitoring and evaluation framework, which is developed led by Cener in Italy in particular, which allows to verify the models for the historical period as they run. And it also embeds certain impact sector models as well, four or five models at the moment. Just to show you another beautiful visualization, the point here is really it's allowing to go from 100 kilometers to 5 kilometers. And on one hand, of course, we hope to have better representation of processes at local scale, but it's really an important point that Paco always makes, and he made it just before, is this creation of globally consistent information at the scales where today we downscale. So this is an important point. And why would you want to go at these scales? You know, because we do that regionally, of course. And this is a really nice example. It's a nice combination of horizon funding through NextGEMS, which is another project ECMWF is very involved in, with the Digital Europe program funding, and it's showing that basically by going at these resolutions, you start to see the cities. This is, on the bottom plot there, you can see the surface temperature from Landsaf, anomalies over 5 years, and you can see Brussels, you can see the area around Bonn, you can see Paris, but you see them on the top left there. You can see it as well at 4 kilometers. And in the version of the model at 28 kilometers, which is still high resolution for climate today, you also start to see that, but not to similar extent. What is important as well is that the cities were added in the IFS in the last 2 years, and this is also tested in particular in the framework of NextGEMS. And I think Brussels looks quite surprisingly well here. If you think this is a climate model, you can see the diurnal cycle in black, the anomalies from Landsaf in black and from IFS in blue, and you can also see before adding the cities there as well, there was no diurnal cycle. So I think this is quite convincing and important. In IPCC, the new report will focus on urban scale. So I think this is one of the added value where destinationers can bring added value as well. Another thing which the climate digital twin is doing is creating a framework for doing storylines through simulations which are nudged to era 5 actually, and this is work done by Thomas Hugh and his group in the Alfred Wegener Institute, where they nudge IFS FESOM to era 5 over the period, basically running it in near real time if you want, from the last 5 years, and then looking at extreme events. This is a heat wave in 2019, and then do the same exercise in a warmer world. So this is a climate model, but nudge to the large scale to make the impacts of climate change and assess their impact for the same large scale dynamics in a future world and make the climate change impacts more tangible. And finally, one big effort and in Destinationers Phase 2 is using more and more AI and machine learning. And this example was chosen for Florian because he likes olive oil. He's from Bavaria, so he wanted to know whether he can olive olive trees in Bavaria soon. But a joke aside, what the Alfred Wegener Institute is doing together with BSU as well in the climate twin is to build up use large language models to extract information and ease the use of information for climate services, and this is something that can be exploited as well in the framework of Copernicus, of course. For now, it's using CMIP, but it's also using a lot of other information regarding the planning permissions, etc., and then it allows to extract more easily the information that you want. And this is going to be further evolved in the phase 2. So in conclusion, I would say that there was a lot of hard work by a lot of people in a very short amount of time. And the fact that we managed to set up these digital twin workflows on completely new and emerging EuroHPC, with Lumi was just being installed last year, in less than 1 year, reaching a maturity level where we could produce the first integrations from 2020 to 2040, which is a very short projection, and it's also not a full set of simulations, but as a demonstrator, I think that's quite important. And I think Destination Earth can really complement C3S by providing this operational framework to perform the multi-decadal projections and complement all the wealth of information and services that it's provided by C3S, and the two can work really well together. Of course, there is also a need that Carlo points all the time to operationalize forcings and scenarios, and that has to be seen how it will be done in the future, and that's also part of the story, because if you don't have that, you can't do operational projections, which is what we go. And if you want to read more, there is more information about the digital twins, and more will come soon. Thank you.
Thank you very much, Irina. That was great. And well, maybe I want to pick up on a couple of things here, because on the one hand, there is one element, this machine learning or AI supported interface to climate data actually resonates a lot with the thoughts we had and we have in C3S, especially on how to harvest and present information about quality. So the quality assessment, and Shunshui, there is a poster up there about the contract, all the activity that we are doing on EQC. Well, this can actually change fundamentally, thanks also to the AI, and there is a paper, I think at the moment under review with bumps on that. So that's one of the point of contact. The other point of contact is very much on the operationalization of the forcing that Irina was talking about, operationalization of climate projection that Irina was talking about. And well, there are two things I want to say here. One is that we are in the same organization, and we are sharing the corridor. We used to share the corridor. Now in Bonn, things are quite dynamic, so I don't entirely know where my office will be or where the Irina one will be. But we are working hand in hand, and the two programs really have a strong interface. On this operationalization effort, there is a natural first step, and I think Chris mentioned this first step in his talk. And this workshop that we are hosting, and Helene has also mentioned it, a workshop that we are hosting at ECMWF at the end of October, jointly with the IPO, ESA, and this is looking at ways in which climate forcing can be operationalized to feed into an operational system of climate projection. So I was just keen to highlight that. I'm sure you have questions to Irina and to our directors. I would suggest to park those questions and maybe pick those up during the coffee break. Because another point I want to highlight, and this will be our last talk before the pitches for the posters and the coffee. Another point I want to highlight is the value. So we heard from Irina the value that Destination Earth or Copernicus provide to member state by pushing what is possible today. The other ways in which we provide value to the member state is very much linked to observation, which are our bread and butter of all we do. So our last talk is from Paul Poli. You have seen Paul before. Paul is contributing to the effort towards ERA 6, but is also very much leading on all our in situ components. So Paul, I leave it to you. Thank you.
Good afternoon, everyone. So before I start, I would like to acknowledge all the people who have worked on the in situ program in C3S for the past 10 years. I'm just here the messenger of that story. And there are also contractors, there are partners, a lot of efforts in there, CDS team and so on. The other thing I like to say is that in situ is not something that usually gets people jumping on the table. And in fact, looking at you, if you want to jump somewhere, it's probably to the coffee break. But I'm sitting in between, so I'll try to make it quick. So the first thing about in situ is that whatever people will say about it, it's still extremely popular with a lot of users. And in fact, it is so popular that many industries continue to operate their own networks today. They go through the expense of paying for instruments and paying for operations. So that says a lot about the value of those observations for them. The second thing is that in situ, of course, has a long history. That history started essentially with the industrial era, and there has been a lot of changes in the instrumentation, but not only in the data management, generally speaking. And that explains why today data from the past require a bit of work. So when one is talking about in situ, one is not trying to travel back in time. One tries to do the opposite. One tries to take the data from yesterday and bring them into the present so we can use them with our infrastructure. So I'm showing here an example of an image as an illustration of that. This image was obtained by data rescue, so imaging aging records that were held here in Belgium at the Royal Meteorological Institute, and a copy of which is also in Africa. Those are records from an African collection called ACMAD. This is their international organization, but ACMAD has a lot of the records over their country going back several decades. And so this was imaged, so now it's digital, so even if the paper records are lost, we have a numerical copy. But you can see that using this information today in a computer still requires a substantial amount of work. So this is what this program is about. So we're going to look here at a small animation of what data went into ERA 5. ERA 5 is this product you've heard about, and at the bottom you see a map which has been centered on Europe, strangely, and it's showing the in situ components. There is one image per year, and I want you to pay close attention to the data gaps, which are, for example, for surface pressure in the early decades. So as the animation is playing, you can see some data gaps are actually getting filled, and then we're starting to get upper air components, and then in 1970 we start having the satellite components. But it's only not until the mid-1990s that we start having a more complete picture with more sensors. And if we look ahead, this picture will change enormously in the next years, as there are 60 satellite missions in planning or in development at ESA. So this picture will become more crowded, especially with satellites. So what have we done in C3S? We have not collected in situ observations ourselves. Those data are made by institutions, as I've mentioned, or by private entities. What we have done was to work on data rescue coordination. That's the first thing, to ensure that people know who is doing data rescue. So for this, we have now a web portal, which is merged with the WMO web portal, and so anybody can see what is happening. Another type of action we've led has been to improve and review the best practices for data rescue. It's something to make a photo. It's something else to understand and keep which metadata you need for the photo to be usable. So this has led to revised guidelines at WMO standard. And looking ahead, we're looking to make this become probably an ISO standard, so it widens to all the environmental type of data. Another type of work has been to consolidate in situ data collections from national institutions or international collections. And this data set here, is example, is EOPS, run by KNMI within a C3S contract. And it's part of 10 data sets which are on the Climate Data Store. So those data are free. You can look at them and you can make your own judgment. And they are actually being used regularly to assert the ground truth with respect to changes that are seen in ERA 5. Another aspect is probably less interesting. It has to do with what language do the observations speak. So we know that there has been some exchanges, of course, under WMO with some old formats, but those formats have kept changing. And for that reason, we've come up with our own data model. So it's about data model, not really data format. But this data model is now the referential for the evolution of the CDS. And it's also been adopted by the EU-funded Rodeo project, which is also partly funded by UMetNet for all their climate APIs. This is to ensure that exchange of climate observations can be done with the same language. Another aspect has been data rescue actions, and I've shown an example with the ACMAD. But we know there are many more records waiting to be rescued. So this picture summarizes the type of innovations we've applied to the in situ program. So our foundations are the National Climate Archives. This is really where the authority lies with, and who has sovereignty of networks and who knows what happened. But sometimes things are exactly perfect. So some data may end up in international data collections. So we also need to talk to these. We also talk to GCOS on a regular basis, and we apply their requirements to make sure that we are working within the limits given by GCOS. We're not going to spend a lot of money on digitizing data 1 second resolution, for example. That's not the priority. And then we have the work on the procedures. We're also operating a data deposition service. So anybody who has rescued observations can go there and upload the data. Of course, there is a check on authenticity at this point. We are also working to reconcile the data with the metadata so that the users have a more complete picture and they know what they're looking at. We have also now authority from WMO to mint what is called WIGOS station identifiers. So this is like the unique ID for each station. So this we will only do once WMO members confirm they are not interested in picking up the history for those stations. All this is done under traceable processes, and I have more aspects here, which I will go quickly. I will just mention that when you're getting data from the Climate Data Store for in situ, you will know who provided the data to us, you will know what is the data policy, and you will know the quality flag. All those three components are always present, and this sets us apart from many other sources of data. And the other thing is that it's repetitive. We talk to these archives on a regular basis, so we update and so on. So the impact this is doing, that we're getting from this is, of course, in terms of coverage. If we're looking at a map, you can see here over several decades. This example is for a comprehensive land surface data set, which is served on the Climate Data Store. And you can see changes in the observing networks. And you can also see that we still have some long-term gaps, for example, over Greenland. But now, thanks to interactions in particular with Copernicus in situ as well, we have worked with several partners to patch those gaps. And over Greenland, we now have a historical data set. We are also working with, of course, the European weather institutions, the MHS, who are now have now started implementing climate APIs. So we are getting the data from there directly, using the API mechanism, for example, for AMET, Météo France, SMHI, and others. So all those data will go also for assimilation into ERA 6. And this is where the second impact I would like to illustrate is not about quality, but it's about quality this time. So what you're looking at here is the vertical profile. I'm sorry, it's not a fancy animation, but it's just a vertical profile of improvements in terms of standard deviation of departures with respect to radio sound temperatures. It's a bit of a mouthful, but it's telling you when you went from ERA 40 to ERA interim, on this metric, we made an improvement on the order between 10 and 15%. That's the red line. When we went from interim to ERA 5, then you're getting the blue line. The improvement is also depends on the levels. In the troposphere, or if you're looking in the stratosphere, is not much of an improvement, but it's also within the same ballpark, 10 to 15%. And then from going ERA 5 to the pre-ERA 6 system, so that's the system we're building right now, as was mentioned, discussed this morning, our initial runs are giving us an improvement shown in green, which is also throughout the column, and actually quite substantial in the stratosphere. Now, those are with the data that we've always used in reanalysis from ERA 40, from ERA interim, data obtained from the GTS, and so on. If we replace these observations by observations that have been reprocessed, coming from this contract, applying consistent quality QC, looking for duplicates, adding sources of information from international collections, going back to national sources, applying the latest understanding of how a radio sound goes up in the atmosphere, is actually drifting, reconstructing a trajectory, using that in the assimilation instead of the original data, then we're getting the curve in gray. So this curve is an additional improvement on top of the improvements we're getting only through the reanalysis system. So this will be an addition. So I hope I convinced you that this activity had more to do than just creating data sets, but the visible part is that we're basically putting together data sets for everybody to work with, and knowing the data policy, and people can use that for whatever they want, including reanalysis or including AI training. We are also putting together gridded data sets like EOPS. And also what we're doing is we're adding a bit of capacity at the European level to work on climate data from in-situ observations. It's not a huge part of the funding, it's a small part. And we also see that with greater data sharing under the EU Open Data Directive and also the WMO Unified Data Policy, there will be less data rescue needed in the future, because if data are shared in the first place, they are less likely to be lost. Nonetheless, there will still be a need for coordination and to continue upgrading or doing the maintenance of the data so they remain relevant and useful. So many historical records still need some help, and we can probably help. Come and talk to us if you have some of those records. And yeah, we're looking to enhance also the quality of ERA 6, and we know this will probably very likely help future AI through the training. So I'll finish with one shameless advertising for free posters on in situ, which are upstairs, and thank you for your attention.
Thank you, Paul. So this was our last speaker, but it's not the end yet. You are not quite ready to go for the coffee and the poster. I leave the floor to Stein for introduce poster pitches and a couple of additional talks at the end, very, very short. Stein, floor to yours.
Awake? Yes? So, the most important. At 7 o'clock we have an evening reception. It's not here, it's in the Bellevue Museum. So you have to walk about 20 minutes to get there. I think I heard some rain, so I hope it will be dry to get there. And before that, so this is something which you can find also in the online program where the museum is. Before that, at 5 o'clock, we have a group picture. So we have to watch our colleagues of Copacom. Last week we already tried it twice. So they will design how we should stand to have this group picture. So that's at 7 o'clock, and at 5 o'clock, sorry, and between 5 and 6 o'clock you have the poster and the demo sessions with a coffee break and some other things. So to initiate these posters and demo sessions, I would like to give the floor to a couple of colleagues who can do an elevator pitch to illustrate on what these posters are. And for those people who were not here yet, the poster sessions are on the first floor, as well as the demo cases, which you can see in the different rooms. And they have, I found out, names of grapes, and that's because this venue used to be the wine palace in the early 1900s. And you have to go outside and look at the facades. You have some beautiful Art Nouveau inscriptions of other wine houses which illustrate this. So let's start now with the poster sessions. Hans.
Thank you very much. Well, I'll be very short. So I gave a presentation today about where we go with the ERA 6. So if you want to learn more about what ERA 5 is and what it's about, and want to learn where we were going with ERA 6, please come have a look to our poster. It's a little bit hidden upstairs, but you will find it. Well, thank you very much.
Thank you, Hans. Jonathan?
Hello, good afternoon. My name is Jonathan Bevier. I'm working at Meteo France Research Center in the seasonal forecast team. And in our poster, we present the evolutions we plan to have in our next operational seasonal forecasting system, the choices we are still facing, and focus on the CIS component, which is the component which has changed the most, and for which we expect many improvements, especially for the initial state of the CIS forecast. So please come to have a look at the poster. Thank you.
Thank you, Jonathan. André?
Thank you. So I represent here the consortium working on historical satellite data rescue. So in this project, we provide for analysis purposes some of the oldest satellite data ever measured. Some of these data sets go back all the way back to 1960s, 1970s. So why look at such old data sets? Well, one simple answer is that they can actually provide an important constraint for models in regions where there are no other data sets available, especially in the upper atmosphere. So in my poster, I would like to focus on one particular aspect of this work, which is what we call the data inventory. And we have actually prepared a Microsoft Word document as well as a web page in which we describe in a synthetic manner these oldest data sets. So these documents are meant for community use, so it would be great to get some feedback on them. So if you want to hear more about it, please come to the poster.
Thank you, André. Sam Young.
Yeah, hi and good afternoon. So my poster is about ERA 5's little sister for Europe, ERA 5's European sister. So SARA, Copernicus European Regional Reanalysis. So the poster is mainly about the main challenges or tasks that we have in the ongoing project. So, and that is actually catching up with real time to produce then monthly updates, so real close to real-time updates. Then the second major task is to make a back extension, so extending the dataset back to 1961. And then last but not least, making the dataset a bit more user-friendly by providing actually daily and monthly statistics, which will be available in the CDS. So if you're interested in that, please come to my poster.
Thank you, Semyon. Harald.
So I will present the poster on the CARA-2 system. So CARA-2 is the next generation of the Arctic reanalysis system. We already have a CARA-1. CARA-2 is going to be much larger. It's going to be a pan-Arctic domain. And we are going to run it with 2.5 kilometer horizontal resolution. So we have never run such a large domain with that resolution before. So that's new. We have done a lot of optimization and tuning work to get it running. It's now in the spin-up phase, and we are going to start storing the data in just a few weeks. And in the poster, you can see the first results of how it compares to ERA 5 and how we improve on it.
Thank you. Damien?
So, hello everyone. I'm Damien from the seasonal prediction research team at Météo France. So, as Jonathan might have said just before, we are data providers to C3S regarding seasonal prediction, but we also carry on research on our production and on all C3S seasonal forecasting data. My poster deals with a task we've been implementing within our contract regarding the interpretation of a multimodal ensemble seasonal forecast, trying to extract scenarios from the ensemble that will enable to better interpret the full multimodal ensemble, and so it turns very useful for our forecaster colleagues while devising the seasonal forecasting bulletins. So if you want to know more, please come and see me at my poster.
Thank you, Damien. Mattia?
Hello, I'm Mattia Zaramella from Inside Climate Service. We are in charge of developing the enhanced operational service for the energy sector, and the objective of our work is to build a database of energy indices at a global scale and increased temporal resolution, moving from the older database, which was at European scale. The service will be fully based and operational on the climate data store, and it will include past climate data, multi-model seasonal forecast, and climate projections. The poster is number 24. We are upstairs behind the corner. So, thank you.
Thank you, Mattia. Richard? Hey.
Hello, I'm Richard Mladek from ECMWF, and my poster is about TIG and S2S datasets at ECMWF. If you don't know those datasets, please see in the poster some details. If you know these datasets, the most important is that we are moving the data access of those popular datasets to a new interface. In the past, there were always WMO projects behind those datasets, but they already finished. But because the data archives have been very popular, they've survived until now, and it was already agreed that there will be new 5-year phase supporting those datasets until 2028. TIGI stands for the International Global Grand Ensemble. It started in 2006, and it's a pretty big archive. It has now 9 petabytes of data. S2S is a bit younger. It started in 2015, and it consists of 13 ensemble forecasts and reforecasts from numerical weather prediction centers. So the main message of the poster is that we are migrating the data access to so-called CDSE. It stands for Common Data Common. See this? I'm not. It confuses me with that CDS. It's Common Data Store, but it is Common Data Store Engine, and also CDS and CAMS will be using the same technology. That's the same technology which is behind the Copernicus data store, which was announced yesterday by Angel, and it's open now for test users. The idea is that all users will have the same access to all data stores, and in the future they will be able also to use the same tools for data visualization and processing. Thank you.
Thank you, Richard. Harald has a second poster.
I have a second one, or we have a second one. Of course, we also present already existing Arctic reanalysis, the CARA-1, which is available for a long time series and which we are continuously updating. So the poster focuses a little bit on how it improves relative to ERA5 with particular keywords on extreme events and high impact weather. So
right?
it's hidden in a remote part of the area, so but please look for it.
Thank you, Harald. And then last but not least, Paco.
Thank you. I'm just introducing the poster on behalf of some colleagues at the BSc and the Met Office. It's about the ASPECT project that has been mentioned already by Anka. It's a European project in which there are several partners all around Europe. Apart from making and exploring new kinds of climate projections and climate predictions and how to bring them together to try to bridge a gap between seasonal, multi-annual, decadal, and projections, the main concept of and the main driver behind the ASPECT project, and this is what you'll see in this very sleek and very conceptual poster, is that the whole thing should start from the questions to the users and identifying user requirements and then going back to try to understand if there is predictability, if there is skill, and what are the drivers that might be behind or not the answers that the users are expecting. And instead of thinking the way of provider side, to start thinking a bit more on the user side, that is the main driver of the whole concept. Thank you.
Thank you, Paco. So these were the slides, these were the posters, and now we also have an elevator pitch for the demo sessions. And there you see the different rooms with the grapes. And the aim of these demo sessions is that you can really go to these rooms and have a closer look at what I want to present on that specific project or demonstration of an application. So I would like to give the floor to Anka or Nuria.
Hi everyone, I am Nuria, I am working at BSc and we are developing a tool, a suite, in this case is Sunset. It was already introduced by Patricia because we are using this software suite to assess the seasonal climate forecasts that are being produced in C3S. But the aim of the tool goes beyond that because we aim to also produce climate services based on climate forecasts for subseasonal, seasonal, and decadal predictions, and we are trying to produce tailored products following user requirements as well. So hope you see you upstairs.
Thank you, Nuria. Then,
yeah. José Manuel Gutiérrez from Santander will be presenting the interactive atlas. You may have heard about that in the different presentations. So András, Daniel, and myself can help you to explore details on the reanalysis projections on a number of visuals and analysis dimensions, including time slices, global warming levels, global, regional, for countries, for customized regions, a number of options. So the idea is to explore with you details in the atlas, and more importantly, we are working in the second version, in the first big update of the atlas, and we would be very happy to hear about your opinions, about the useful things to be included, data sets, indexes, everything that you think may help to improve the service will be well received. Thank you.
Thank you, Jose. Angel? Ah.
Here I am.
here I am again. We will be in the room C3S. We will be talking about the C3S. So we will be presenting the new system in case you have any question about how to enter into the new system or how to use it or what is there or what is new. And also if you have questions about the old system, we will be there to answer whatever question you have. Thank you.
Thank you, Angel. And this brings us to the next one at the end, James.
Thank you. Hi everyone, I'm James Vandell. I'm a software developer at ECMWF, and I've got a little demo booth to show you EarthKit, which is an ambitious new open source software project being undertaken by ECMWF. So it's the whole point of EarthKit is to try and simplify all of the different steps in the common processing chains that we all do day to day as scientists. So data access, processing, and visualization. So yeah, I've got a few examples to show you. Can have a bit of a play with some CDS data using EarthKit. Yeah, so come on over and have a look.
Thank you, Viv. And now, last but not least, Vivian.
Hello everyone, I'm Vivian Mavel from BeOpen, and I'm the very last one. So I think the next best thing you can do after this is to come upstairs and have a look at the European Climate Data Explorer, which we have co-designed with the European Environment Agency. And so if you come upstairs, I can show you how you can explore 38 different climate indicators, which you can explore over the 80 years which have just passed, and which were so using ERA5 and the 80 coming years, which we have computed using Eurocordex mainly, and it'll be a pleasure to get some of your feedback too.